Hello, in this session we will see the need for modulation. Modulation is basically a process in which some characteristic of a high frequency carrier signal is varied in accordance with the instantaneous value of the modulating signal. So basically we can think that the modulation is a process of frequency up conversion wherein the low frequency modulating signal is superimposed on a high frequency carrier signal. So let us see why modulation is necessary. Modulation is necessary for basically three reasons: height of the antenna, narrowbanding, and multiplexing. Height of the antenna. We know the relation between the frequency and wavelength of a signal is given by the formula C is equal to f lambda, where C is the speed of light and it is given as 3 into 10 raised to 8 meters per second. To understand the relation between the frequency, wavelength and the height of the antenna, we need to remember that the height of the antenna for transmitting a signal is approximately lambda by 4. So according to this relation, if I assume that the frequency of the signal to be transmitted is 1 kHz, then according to the formula we can evaluate the value of lambda to be equal to 300 kilometers. Corresponding to this, the height of the antenna must be 75 kilometers, which is not at all a practical value. To make it a practical value, what we can do is we can do superimposition of this 1 kHz modulating signal on a carrier, say 88 MHz. Then again, according to the formula C is equal to f lambda, we can find out the value of lambda, which comes out to be 3.4 meters, and corresponding to this, the height of the antenna now which is needed will be approximately 0.85 meters, which is quite a practical value, and this is easy to construct. The second reason why we do modulation is narrowbanding. So to understand the term narrowbanding, let us assume that the range of frequencies to be transmitted is from 250 Hz to 15 kHz. Corresponding to 250 kHz, the height of the antenna required will be 300 kilometers, whereas corresponding to 15 kHz, the height of the antenna required will be 5 kilometers. That means if we are transmitting 250 Hz as well as 15 kHz simultaneously, we need the antenna which will have a variable height from 300 kilometers to 5 kilometers. So practically changing the height of the antenna dynamically while the signal is being transmitted is not possible. Whereas on the other hand, if this signal is superimposed on a carrier frequency, let us assume 88 MHz, which comes in the band of frequency modulation, then we can say the modulated signal will range from 88.00025 MHz to 88.015 MHz. Now if this is the signal which is to be transmitted, then the height of the antenna required will remain practically same. So this was the second reason why we need modulation. So in narrowbanding, basically what we do is consider the first frequency range which we had, that means 250 Hz to 15 kHz. Now here the ratio of the highest frequency to be transmitted to the lowest frequency to be transmitted was 15 kHz to 250 Hz. This ratio was quite large, whereas the second case, when modulation was done, the ratio of the high to the lowest frequency is from 88, or rather it is nearly equal to 1. So this is what we mean by narrowbanding. The third reason why we need modulation is multiplexing. Let us assume two stations are doing music broadcasting without modulation. Both the stations will be transmitting in the same frequency band, and the users are not able to tune to these two radio stations, whereas we can assign different frequencies for transmission to these stations so that they can occupy different frequency bands either from AM or FM or television. So in this case, any receiver will be able to tune to the desired signal, and the desired signal can be received due to multiplexing. So these are the basic three reasons why modulation is necessary: height of the antenna, narrowbanding, and multiplexing. Thank you.